Hey, good morning, Tableau Conference. Welcome to Jedi Charts. I'm Chris Fellows, a senior software engineer at Tableau in the visual analytics team. I like efficient database queries, drawing pictures with math, and British rock music. I'm excited today to introduce two Zen masters whose dashboards go far beyond the ordinary. In their day jobs, Radi Zakovich is a data analyst at Telstra Inc., and Adam McCann is a specialist leader at Deloitte Consulting. Adam is, and I got this from his LinkedIn, a recognized award-winning data science executive with 13 years of experience in analytics. Yeah. His Game of Thrones Season 6 viz has more spoilers per pixel than any viz I have ever seen. And Radi has spent the past 4 years as technical recruiter, data analyst. He now spends his days and nights pushing Tableau to its limits, exploring the stories behind the data. He's created vizes from American football to analyzing the effect of the Marvel franchise on Disney's bottom line. Adam and Radi's blogs and portfolios showcase interactive visualizations that go beyond the boring bar chart and delight the senses with detailed dashboards. Their blogs feature bump charts, spiral graphs, gauge charts, dynamic shading, and triangle plots, to name a few. And what you don't know yet is they have created some vizes for some of my favorite bands. Adam's well-known viz of the Beatles' greatest hits, and Radi's viz of the first 10 Queen albums are some of my favorites. Now all we need to do is create a Led Zeppelin viz to complete the trifecta. It's coming? But I'm not sure that the full beauty of Robert Plant's lyrics can be contained in a single viz. Here to show us I'm wrong, please welcome Tableau Zen masters Adam McCann and Radi Zakovich.
Good morning, everyone. Welcome. Thank you for coming. This is Jedi Charts, creating custom charts in Tableau. I'm Adam McCann. Radi's going to come after me, and hopefully we're going to show you some cool things today. The purpose of our session is to show you how to create anything you can imagine in Tableau. We want to do one caveat. Some of the concepts we're going to go over are technically complex, both some of the things we're doing in Tableau and then some of the math that we're doing in the background are complex and could be intimidating. And the purpose of our session is not to walk you through how to create these specific visualizations, but hopefully to inspire you to create your own visualizations and prove that you can really do anything with Tableau, create any chart you can imagine. So what do we mean when we say custom charts? This is really anything beyond your normal chart types in Tableau. As you know, there are 21 default chart types available to you in the Show Me window in Tableau, things like bar charts, pie charts, scatter plots. And then thanks to the great folks in the Tableau community, folks like Chris Love, Jeffrey Schaefer, and Chris DiMartini, and many, many more, we have seen a lot of other data visualizations and how-tos of things you can create, of other custom charts you can create in Tableau. Things like Maramako charts, Sankey diagrams, and gauges, which are awesome. But when we talk about custom chart types, we're not just talking about chart types that you see in other tools but are not available out of the box in Tableau, but also the ability to create anything you can imagine. And I got this quote actually last night from Jonathan Drummey via Joe Mako. Tableau is a data-driven drawing tool. You can really use Tableau to create anything you can imagine. And so not just creating charts like area bump charts that you might see in another tool that aren't available out of the box in Tableau, but really drawing anything you can imagine. And when I think of the most talented data visualization people in the world, I think of people like Nadia Bremer of Visual Cinnamon, who created this Lord of the Rings loom plot, which is not a typical chart type. It is something that she created in her mind and put to work. And it's a beautiful visualization of Lord of the Rings characters communicating across one another. This visualization by Nadia's partner, Shirley Wu, of 4 Years of Vacation. This temperature radial by Tom Shanley. And then obviously the great work of the folks at the New York Times, who are always pushing the boundaries of data visualization. This election forecast Sankey chart and this election cartogram. But all of these data visualizations were created in D3, an open source JavaScript library where people can create default chart types like bars and lines, and all the beautiful visualization examples that I just highlighted here before. But Roddy and I's hypothesis is that any chart type is possible in Tableau by following 3 common steps: plot points, connect points, and format points. And that's what we're going to walk you through today. All the chart types that we're going to run you through follow these 3 basic steps, and all of them are essentially scatter plots, where the x and y axes are continuous variables that we drop into the columns in the row shelf, connect those points using another marks card, whether it be color or path, and then format those points to add style and context. So the first example I'm going to walk you through is not a data visualization at all, but something else entirely. So I created my x and y coordinates in R using a package that converts images into coordinates. I then create a color from those same coordinates and drop it into the color shelf and connect those points, and then format those colors to produce a recognizable image. Van Gogh's The Starry Night. So this is a complex way of converting data, an image, into data and into a data visualization. And this obviously has no practical business application. You really don't generally have a need to plot hundreds of thousands of points, color those points, and create a data visualization that looks like this. But the purpose is to show you is that Tableau is a drawing tool. You can render and visualize anything you can imagine. And thank you to Merlin Buick for the color palette I stole from him. The hardest part of this step of creating the Starry Night, and really of all the visualizations that we're going to walk you through today, is the first step, plotting points. And some of that requires processing in another tool. Roddy tends to use Python and SQL, and I tend to use R, Excel, and Alteryx. And this is where most of the work takes place in terms of plotting your points and getting them to a position. But everything we're going to walk you through today is very straightforward. You don't need to learn these tools in order to do the calculations that we're doing to render our data visualizations. It's mostly for data prep and to put our data into position to create our data visualizations. But one warning, just because all chart types are possible in Tableau, the question is to be asked, should they be? Should you create these overly complex data visualizations? Tableau is nice. It is a simple, easy to use drag and drop tool. And Roddy and I and several others are making it more complex, adding complexity to it that might not need to exist. And the visualizations we're creating are rendering lots of points. They're complex visually and computationally. And so you have to ask the question that Joe Mako posed, is the juice worth the squeeze? Is it worth creating these complex visualizations in order to produce a data visualization, or in order to produce, to drive insight? And that's a question that you have to ask yourself. What we're not saying is that these charts are better than your typical bar charts or line charts, just that these charts are available to you, and this is how you can go about creating them. And you have to make the call of whether it's worth the effort to create them and render them and communicate them in Tableau. So the next example I'm going to walk you through is this Bible viz created by Chris Harrison, which shows Bible cross-references. And I wanted to create a similar type of arc diagram in Tableau. So I drew this beautiful data visualization, usually on the train on home from work, where I wanted to show Supreme Court justices' tenure over time as an arc, where the length of that arc is the tenure of a Supreme Court justice from the point they started. The height of that arc is what age they were when they were appointed. The taller it is, the younger they were. And then whether they were on the top or bottom was whether they were appointed by a Democrat or Republican, and the color would indicate the same. So how do I go about creating that in Tableau? Again, I'm going to walk you through a GIF, dropping my x and y coordinates to drop points and create my marks. I got to add a specific Supreme Court justice and the points I need to create my lines, convert those to a line chart, and add a color to indicate which party appointed them. Blue on top is Democrat and Republicans on the bottom. And then I'm going to add markers to indicate the total tenure at the bottom. So it's actually a marker placed on the x-axis indicating the total tenure. And then lastly, I'm going to make it pretty, adding some interactivity, some titling, some legends. And what you end up having is something that looks like this: an arc chart created in Tableau by plotting points, connecting points, and formatting your points together. And the last example before I go into a detailed walkthrough is this data visualization inspired by Van Gogh's self-portrait. I wanted to create the brushstroke effect that Van Gogh uses to highlight features in his face. And so I drew this data visualization, again on politics. I'm from Washington, D.C. It's a lot about politics, I'm sorry. So what I want to do is create a brushstroke indicating the extent to which each state voted for a Democrat going to the left and a Republican going to the right. And the angle at which it points is the extremity to which they were a Democrat or Republican. And I want to have a row for every election for the last 12 years. So I wanted those marks to look like painting brushstrokes. So what do? I create my X and Y coordinates. Again, I used R. I drag them into my columns and row shelf to create my points. I then drag in year to create rows, convert it to a discrete dimension. I then add in specific states, so I create that brushstroke effect that goes outward as a state votes more to the left or more to the right. Add color to indicate whether they voted Democrat, Republican, or independent. And the last thing I do is I want to add some formatting, some titles in between, so I indicate, oh, I'm sorry, I skipped a step. The thickness of the brushstroke is the total number of votes or the size of the state. And then I want to add a marker in between indicating the year of the election, who ended up winning, and what party they belong to. So I add in a dual axis, add in the winning president's name, the year of the election, format that mark, set the axis to a dual axis, and then synchronize those axes so it lines up into the middle. And the last thing I do is hide my axes, make it look pretty, add some interactivity, and now what I have is a data visualization of brushstrokes indicating every state's tendency to vote Democrat, Republican for the last 12 elections. Oh. Thank you. So these are examples that are sort of outside the box. They're different than what you typically see in Tableau. And I've ran through those 3 examples pretty quickly. We're going to be posting these Tableau package workbooks to our respective blogs. Roddy is at Data Tableau and me, and I'm at duelingdata.com. So if we ran through these quickly and you weren't able to follow, don't worry about it. You can go and download the workbooks and reverse engineer it, including the next data visualization, which I'm going to go over, which is on Game of Thrones, the greatest television show ever. So I love Game of Thrones. I'm obsessed with it. I have made multiple data visualizations about Game of Thrones. And one of the more complex data visualizations I made, I wanted to visualize the history of specific characters over the course of the show. And so at the end of season 5, I wanted to show the history of a character, how often they are appearing in every episode, what family or house they belong to, and when they died. So I'm going to warn you, if you have not for some reason watched Game of Thrones up to season 5, I'm going to tell you people who have died. So I'm not going to say it out loud. It'll be on the screen, so if you do not want to find out, just don't look at the screen. You have been warned. I am not responsible for this. So again, I drew this data visualization, which is a weird custom visualization that looks kind of like an S shape. The visualization at the top is essentially a bar chart showing the total number of appearances by character. Every bar or line is a specific character. Then below that, I add a stacked bar chart indicating the sigil or the house they belong to. And then finally, I have this sort of S shape indicating the flow of that character over time with a marker indicating when they died, most likely, or when they debuted. So how do I create this in Tableau? So the hard part of this data visualization is the bottom part. The top part is essentially just a bar chart, number of total appearances by character. The middle chart is just a stacked bar chart, total number of characters by sigil or house. And then the bottom part is complex. It is a spiral chart and showing the history of the character over time. I wanted the character's history to start at 12 o'clock, go around until either they died or end at 9 o'clock on the clock face right here, if they had survived miraculously. So how do I create this in Tableau? That's the tricky part. So first I got my data. So I scraped this data off of Game of Thrones Wikipedia fan page that I frequent, where it indicated every single character, the number of appearances that character made for that episode, the ID of that episode, the name of that episode, and then I added in an event related to that character if it was pertinent. I will not say the event up there. So what do I need to do? I need to create X and Y coordinates to plot points on a circle. My S shape is essentially a circle. So in order to do that, I need to create 3 continuous variables in Tableau: an angle, an X, and a Y. An angle is just giving me a point for every point on that curve that I want to plot. So the angle here is 360 degrees along a circle, divided by 2/3 times 100 times the episode ID, 1 through 50. This visualization ends at season 5, so there are only 50 episodes, 10 episodes a season. Then in order to create my x and y coordinates, I use a parametric equation using that same angle. The square root of 2 times sine of angle times pi divided by 180. Y is the same, but with cosine. So now I have every character, every episode, the angle, and an x and y coordinate on a point on a circle. So when I go and drop that visualization, or those marks that I just created into my columns and row shelf, I have a circle. That is not what I want. I want a custom spiral, something that looks like 3/4 of an S. So what do I need to do? I need to move these points in the upper left quadrant of the circle down so that they follow the same pattern, and then move them up again so it starts at the top of the 12 o'clock and connects to my stacked bar chart. So how do I do that? I create a new x and y coordinate. Modify the angle, so where the angle is greater than 50, so where I go beyond the 50th episode, I want to have a new angle where I subtract 17 from the episode ID. Where that is not the case, I want to use the old angle I created before. And I want to create a new x value called x flipped and y flipped, use the same parametric equation, but using the new angle I created. So when I drag x flipped and y flipped, I have half of, or 3/4 of a circle. This is not what I want to create. And what happened is the circles that were in the upper left quadrant are now stacked on top of the circles on the bottom left. So I need to move those circles up. So I create a new value. My x-axis is right. It is positioned correctly along my x-axis, but I need to move my y values up. In order to do that, I just change my y value, and I have a new value called y flipped up, where if it's beyond the 50th episode, add 31.1 times 2, which is the point on the y-axis where I want it to appear. Where that is not the case, continue to use y flipped. So use x flipped up, or x flipped, and y flipped up. Now I have my semicircle, or my S shape. And this is closer. This is the shape I wanted, and this is where I was stuck for about 5 days of how I got to this point, and then I got for a while. The next thing I need to do is I need a point for every single character. So I want 50 points times 20 characters, and so I want a point along that semicircle for every character, and then I want to add a buffer so that the sigils or the families are spaced next to each other. So I just created new final x and y coordinates. X final is x flipped up, which we just created, times a character ID. Every character has an ID 1 through 20, and a buffer or a space in between the different families. So the Starks and the Targaryens and the Lannisters aren't right on top of one another. So x final, y final, that's looking closer. Those are a bunch of circles, and I don't want a bunch of circles. So I've plotted my points successfully. I finished step 1. I told you it was the hardest step in the process. But now I need to convert this to a line chart and then connect these lines together. So what do I need to do? I go to my marks card, convert to a line. That does not look good. So I grab this path ID. This is giving me a point for every point along my S shape. And so when I drag path into my path shelf, boom, now I have the shape that I want, with a line for every single character, spaced by the sigil of the family they belong to, in the shape that I wanted. So the last part is to color and format and add context. So thankfully I have sigil or the house they belong to, blue for Stark, orange for Lannister, or I'm colorblind, orange for Baratheon, and yellow for Lannister. But what I wanted to do is I want the line to end when the character ends, when they die. And so I don't want the line to continue all the way around to 9 o'clock on the visualization. So what I do now is I convert the background of my data visualization to black, because it's Game of Thrones. Black is awesome. And I add in sigil color and alive status, which is a group field. And I dragged it into my color shelf. I resort. And now I have a line that starts here and it ends when the character dies. Close your eyes, but these folks did not do well. So I'm most of the way there. I have my data visualization, I have my S shape. I want to add marks, so I add in dual axes to add in marks to indicate what occurred. So I add closed circles when a character dies, and I add open circles when a character debuts, a new character. And then the last thing I need to do is combine these charts. So I have my custom spiral, which is the most complex to build. I then create a stacked bar chart it's just number of characters per sigil, and a bar chart, number of appearances per character. I float all those together, and now I have a visualization that's interactive when I hover over. And the last thing I do is I add some style and color legends and some text and some formatting, and this is the finished product. Thank you very much. So that's the end of my session. Roddy's going to come up here and show you some awesome stuff as well, and then after he's done, we're going to do some Q&A. So thank you very much.
Hey, good morning, everyone. Can we give another round of applause for Adam there? That's awesome. Thank you. Yeah. All right. How's everyone doing this morning? Good? Oh, come on. We're going to see some really cool stuff. Come on, how you guys feeling? Good? There we go. All right, so the first chart I'm going to walk you guys through is how to create an area bump chart, or ABC. Before I start, can I just get a kind of show of hands? Who actually knows what an area bump chart is? Okay, so the people that follow me on Twitter. Got it. All right, so an area bump chart, as the name applies, is actually a hybrid chart. It takes all of the strengths of a stacked area chart and all of the strengths of a bump chart and combines them together. So it allows us to see how distribution among categories change over time, as well as their rankings. So this is an example from the New York Times Upshot. They're using something other than a measure to change the ordinal rank, but this gives you a basic idea of the shape that we're going to be creating. So the first thing we need to do is understand some concepts about Tableau. In tools like D3, if we have 2 points, we can actually specify the type of line that we can want to connect those points with, whether that be a sigmoid or a Bezier or what have you. In Tableau, unfortunately, we don't yet have that ability. So in order for us to create these S-like shapes, or what Adam showed in the Game of Thrones viz, we actually have to plot the points. So we do this by creating data models, or data scaffolds. This is just a very simple one in Excel that just allows me to create points that I can cross-join to my source data and create all the points necessary to draw these S-like shapes. And if you don't know what a sigmoid is, it's right here in the top right corner. It's really just an equation that allows us to take several points and draw this nice S-like shape between them. So once we have our model and we're able to join it to our data, and for anybody that's interested out there, for this example, I'm just using Superstore, and I've just aggregated to the category and year level. So this chart worked by showing us distribution and rank over time. So the first thing we want to do is figure out how we want to plot our x-axis. Now, since we're doing this by year, we need to show an x-axis that shows things by year. Does that make sense? So what we want to do is create 49 equal points that are going to fall between each year. And that's going to allow us to show our curves, but it's not going to obstruct anything too much. So what I do is I take a path from my data model, which has rows 1 through 49. I divide that by 49, and then I add that to my year. And that's going to allow me to go from 2014 to 2015 in 49 equal points. So once I have, and that's going to be where my x-axis is going to be all the points that are going to go from left to right. I need to figure out how to plot the points now vertically. Now, because this is a hybrid between an area chart and a bump chart, we need to figure out what the percentages are. We need to figure out what the distribution is for each category. So the first thing that we do for the current year is we figure out what the percent of total is for each category within that year. And we can use an LOD function to do this, simply by taking the fixed based on the category and year level, summing the total, sales in this instance, and then dividing that by the year's total. And now, because we're also looking up what the next year is, because we need to be able to figure out what the point is in the next position that we're going to be drawing our lines to, we're going to use a table calc called lookup. And we're going to configure this in such a way that we're able to bring the next year's value into our current partition. So once we have our percentages, really there's 4 main points that we need to calculate. Top position A, this would be the top point of an area chart when you're stacking them. And then bottom position A, and the distance between them is the percent of total for that particular category. So the top of the chart is 100%. And just like our percentage B, not only do we have to do this for the current year, we also have to look up those values for the next year so that we can draw our lines and eventually our polygon. So how do we do that? Well, the first step we do is we do a running sum of percent A. So that's the percentage in the current year that we're observing. And this allows us to stack categories on top of each other so we can work our way up the axis to 100%. And we configure our table calculation so that it restarts every year. And then we throw a custom sort on it so that each year Tableau is going to recalculate the order of the categories. And this is going to be where the rank comes into our picture, the bump of the area bump chart. And like I said before, just like we did with the percentage, we need to look up what that value is in the next year so that we can connect those points. Now, easy enough, the bottom positions, all we have to do is subtract the percentages, and that's going to give us the distance for those 2 years. So once we have all 4 of those points, we need to combine them. Obviously, we can't put 4 measures on the y-shelf. We need to have one continuous measure that we can put on the y-shelf to kind of create our scatter plot of points. So we do this using a sigmoid function. Now, in my data model, I realized that in order to create the shape, I essentially have to create 2 separate lines, a top line and a bottom line. So in my data model, I actually duplicated it or unioned it, and I changed this field called point ordinal to 1 and 2. And what that allows me to do then in Tableau is I can say if point ordinal equals 1, so it's the first set of 49, I want you to draw the top line, that from top position A to top position B. Now on the flip side of that, if it's point ordinal 2, so the second set of 49 marks, I want you to draw the bottom line. So I'm going to move some settings around. This is live, so if it breaks, I'm sorry. So I'm just going to go ahead and pause updates real quick. So it's a little tip for you. If you're ever moving a lot of things around in Tableau and you don't want to sit there and wait for Tableau to calculate things as you're moving things around, you can actually just pause updates, move everything around, and then press play, and it'll only calculate that final move. So I'm just going to take this year fake here. I'm going to change this to continuous. I'm going to drag that onto my column shelf. I'm going to take away measure names here. I'm going to take my curve calculation. I'm going to drag that onto the row shelf. Take category, put that on color. Put my partitioner here on the detail shelf. Get rid of measure values, get rid of measure names. All right, so at this point, we've just been talking about calculations. We've been building out tables. We really haven't seen anything visual yet. So fingers crossed this actually works. All right, making progress. Thank God for that shot of whiskey before this. Okay. So as you can see with this chart, it's starting to come along. We're starting to get the general shape of what we're trying to get at. But you may notice over to the right, it doesn't quite look right. So the problem is, because in Tableau we don't have the ability to specify the line type between 2 points, when we draw a line, we're not only computing the current value, but the next value. So in this instance, my last year in the data set is 2017. There is no 2018. But Tableau is trying to draw the line to that point. So what we need to do is just remove it. So the way we can do that is by using a lookup on the current partition and just checking to see if it's the max date in our data set. Now, if you're out there wondering, well, why don't you just remove 2017? Well, the problem is we actually need to access the values in that year. So if we removed it from the beginning, we wouldn't be able to compute this. So instead, what we have to do is use a lookup calc, because that forces Tableau to be a table calc filter. And now we're manipulating the Tableau order of operations to make this happen at the very end after everything else has computed. So I'm just going to take that and drag that onto the filter shelf here. I'm going to select true. And now we can start, now that that's gone, we can actually start to see the general shape of our area bump chart come together. All right, so I'm just going to go ahead and change this to a line. And that's it. Thanks, everyone. Appreciate it. Now, obviously, so what happened here? This is not what we wanted. This is broken, made some Tableau art. So the problem is Tableau is trying to draw the lines the way it thinks it should. And in this instance, that's not correct. So we need to help it out a little bit. So the way that we can do that is by creating a path calculation. In my instance, what I want to do is I want to tell Tableau to draw the top line going from 2014 to 2017, so going from left to right. And then for the bottom line, I want it to do the opposite. So I want it to work its way down to 2017, and then work its way back to the left to 2014. So if I drag this onto my path shelf here, you can see that Tableau has now correctly connected the points the way that I want to. So now for the awesome sauce. Now to make this a polygon, I'm going to bring all these things together and actually start to see where this actual shape comes about. Now, for anybody that's out there that's wondering, well, how can you make this a polygon? You have points that are not connected. Well, the thing about Tableau is when you use a polygon, you don't actually have to connect all the points, because Tableau is going to figure out any points that aren't connected, and it's going to connect them automatically. So in this case, because I've drawn my path to go from left to right, down, and then back to the left, the only points that are not connected are those 2 positions in the beginning. So if I change this to a polygon, Tableau connects them, and then we have our area bump chart. All right, so this is pretty cool, but we're not done yet. If you showed this x-axis to one of your customers and told them it was years, do you think they'd be confused? And probably. And the reason is because it's not a date dimension. It's not that. It's actually like a floated number. So we need to somehow format this so that we only show it as years, so that our end users don't get confused. Now, because we created 49 equal points as decimals, what we can actually do is just right-click on our axis, go to Edit Axis, and then we can go to the second tab called Tick Marks. And if we click that, we can actually see this thing for major tick marks. If we set that to fixed, what we're telling Tableau is to only draw a tick on our axis every whole number. So anything that's a decimal, it's not going to draw. So if I go ahead and press OK here, you can see that it removes all of those marks in between, and I'll only show where the years are. So now it actually starts to look like a date field to our end users. So we're not done quite yet. We do need to do some cleanup and formatting. So I'm just going to go ahead and right-click, go to Format. I'm going to go ahead and just remove grid lines and zero lines. And I'm not a big fan of axis rulers, so I'm going to get rid of that. And I've been a really big fan of this kind of blue color for anybody that follows me, so I'm just going to use that. Go over to the clean version, and D3 what? Yeah, so, this chart type is very popular in D3, and it's been used in a lot of things online for online journalism. And you may not think it would be possible in Tableau, but if we break things down into smaller components and then work our way up, we can realize that any of these charts are possible. We just have to follow steps and break them down. And then from there, what we can do is even build more on top of this. And we can extend this, and we can add dual axis, and we can add labels. This is something I did for the Iron Viz entry this year about Disney's rise to the top of the domestic box office. Oh, yeah. Oh, this is connected to the internet. OK, anyway, so this is basically showing that's why you have offline backups. Anyway, so this is showing that since 2011, Disney, or Buena Vista, has actually been moved from towards the bottom half of the position, slowly becoming the #1 distributor in the country. And we can see how the percent of total is actually increasing as it's doing that. And taking an area chart and a bump chart alone, we wouldn't have been able to see these two things combined. So this chart actually allows us to get this type of insight that maybe those charts alone wouldn't have been able to do. OK, so the next one we're going to do is called a spiral node link diagram, or a non-ribbon chord link diagram, or whatever other boring name you want to call it. So just like before, does anybody actually know what this is? Raise show of hands. Wow, literally no one. OK, so a spiral node link diagram is simply a spiral chart that contains nodes, which are the circles at the end. And it shows the connections between dimensions. And it uses these nice curved lines to show how all of these things are connected. And the reason it uses a spiral is because it allows to show a lot of dense data in a very confined space. So we're going to go ahead and create this in Tableau. So just like with our area bump chart, the first thing we need to do is set up our data. Now this data model is actually very simple. It just has 2 columns, a path, which goes from 1 to 2 in 0.02 increments, so 50 rows, and then a join column that just allows it to join us to our source data. So I'm going to be visualizing Romeo and Juliet, so a Shakespeare play, and I've just modeled the data to show each character in order by act and scene, and then how many words they said in that scene, progressively. And then I went ahead and did some pre-work with this as well to grab whatever the next position is. So that way I can go ahead and just look up and figure out where along the circle I'm going to draw my lines. So to get into it, just like just like Adam did with his, and just because Tableau and trigonometry, there's a lot of different ways you can do things, I've actually created my angle plot slightly different than his. So I take 1 and I divide it by the max position in my data set. I multiply that by 2, I multiply that by pi, and then I multiply that by my position minus 1. And that's going to allow me to figure out how many points around the circle I need to draw. Now, because I'm also need to calculate the next position around the circle so that I can draw these lines, I do the exact same calc, except I switch position with next position. And that's going to allow me to have those 2 circles on the same points. So now that we have our angles, we need to do our sines and our cosines. We need to figure out, we actually need to plot these around a circle. So the easy way to do this, based on the way that I set up my angles, we just wrap cosine and sine around them. So I do it for both my angle plot 1 and my angle plot 2, or my position and my next position. And when I go ahead and plot these on the columns and row shelf, you can actually start to see these coming along. You don't have to worry about the 2 in the corners, but worry about on the top left and bottom right. This is every position and every character along the play, and then this is the next position along that same circle that they appear in. So obviously this doesn't do us any good. We actually need to connect these points. We need to bring it in so that we have a single x-axis and a single y-axis. So the way we can do that is with a Bezier curve. Now, if you don't know what that is, don't worry, I really don't either. Essentially, it's just an equation that allows you to connect 2 points and draw this nice curve-like shape between them. So the calculation for this actually goes out to Chris DiMartini, who did a lot of hard work and has done a lot of work with this before. But essentially what we're doing is we're figuring out along the x-axis, we want to figure out what our first position is and our next position is around a circle, and we want to draw a curve. And we're doing the same thing for the y. So as before, I'm just going to go ahead and press pause here. And I hope I get 2 for 2 today. Remove that. Drag my Bezier X onto my column shelf and my Bezier Y onto my Y shelf. Fingers crossed. Hey, it worked. Awesome. All right, so just like before, we've been able to plot this. We're able to see that the shape is coming together. And that we're actually able to see this in a circle, and we're able to see these ribbons going along. So now that we've plotted our points, the next step we need to do is actually connect them. Now, unlike the area bump chart, we actually don't have to do any special calculation to connect these points. All we have to do is take the path from our data model. Actually, turn this into a line real quick. So take the path, that 1 through 2 and 0.2 increments, drag that onto our path mark, and now our viz is starting to come together. Now we've plotted the points and we've connected the points. What am I missing? Oh, format the points. 3 steps, okay. All right, we need to format the points. So this play is based on Romeo and Juliet, right? So we probably want to highlight them and show where they're appearing in the different scenes and how many scenes they appear in together. Now we could create a calculation, something like if player equals Romeo or player equals Juliet, then player or others. Seems kind of boring, though, and I like to do things a lot differently in Tableau. So instead what I'm going to do is take an immediate if calculation. I'm going to create a string that contains Romeo and Juliet. And then I'm going to check to see if my players are actually within that string. So this is similar to an in statement in SQL. And if it is, then I return the player, I also return others. So this is going to allow me to color Romeo and Juliet their own color, and then everybody else I can just make something else. So if I drag that onto my mark here, we can actually start to see that Romeo and Juliet are in this nice orange and blue color, and then everybody else is others, and now we can start to see them throughout the play. I'm not really sure what happens here at the end. No spoilers. All right, so this is great. They're not really popping out a lot, though. I feel like we can maybe make them a little bit thicker so they really stand out compared to everyone else. So what we can do is create a Boolean calc on the one that we just created to check to see if it's others. And if it's not, we return true, else we return false. And that's going to allow us to make Romeo and Juliet, their lines a little bit thicker and then everybody else a little bit thinner, so they really pop out. So if I take that size calculation and drag it onto the size mark, we can actually see that they actually come out nice and bold. We can actually start to see them a little bit better. So we're not done quite yet, though. So if you notice in the example that I showed earlier, it had nodes. It had these circles around it that kind of brought the whole thing together and made it look a lot cleaner. So we could use a dual axis to do this, but why waste it? Maybe we want to do more things with our dual axis later. All we want to do is draw just a simple circle at the end of these lines. So what we can do instead is we can take an immediate if and check to see if our path is equal to our int path, aka is our path equal to 1 or 2, the end of our lines. And if it is, then we're going to draw a Unicode circle, else null. So if I take this and I drag this onto my label shelf here, you can actually see that Tableau is now going to draw a bunch of circles. Now this doesn't quite look too good right now. We actually need to format these. But you can actually see that Tableau is actually rendering all of these circles, and I haven't added a second axis. So what I can do then is I can go to my label mark, and I can actually start moving some things around. So I want these to be right at the end of the lines, so I'm just going to center it on the horizontal and center it on the vertical so that they end on the lines. And then within my font, what I'm going to do is I'm going to match mark color so that they're same color as these lines. And then I'm just going to crank up the shape, the size a little bit so that it looks a little bit nicer. So just like that, without even having to add a dual axis or really having to do anything complicated, we've actually added circles to the end of our lines simply by just manipulating the text mark. So after this, the next step is just cleanup. So right now this is kind of an oval, so I want it to be more of a circle. So I'm just going to control and press to the left so I can actually make this a circle. I don't need to show these axes because they don't make sense in context. So I'm going to go ahead and remove these by unshowing the headers. I'm going to click Format. I'm going to go ahead and just remove all my grid lines and zero lines as I did before. Get rid of any kind of axis rulers. And I really like that blue from before, so I'm going to go ahead and use that. And that gray that I originally picked didn't really look too great, so I'm just going to go ahead and edit colors. I'm going to click Others. I'm going to double-click this, and that's going to bring up my color palette. I'm going to go ahead and pick Color from Screen, click that, and then just kind of lighten this up just a little bit. And then I'm going to press Apply. And just like that, we've created a spiral noodling diagram in Tableau. So at this point, I kind of want to go back to what Adam was saying earlier about, from Joe Mako, is the juice worth the squeeze? Is it worth it to go through all these complicated things to create these charts? And my answer is, yeah, it is. Because it's not about the chart. It has nothing to do with the end result. It's about the journey. It's about taking on these complex problems and figuring out how am I going to do it. Putting Tableau, putting it on its head, spinning around, and looking at it from every angle. Opening up your mind, being creative, being imaginative. Figuring out, how can I manipulate Tableau and the data source to create these different things. And it's through that process, it's through that journey that you really start to master Tableau and understand it as a data-driven drawing tool. And that as long as you keep pushing, and as long as you believe in yourself, really, you can plot and connect and format the points. You can create anything in Tableau. All charts are possible, even something like this. So, thank you. So before we start the Q&A, Adam and I wanted to just recognize, so Mandalay Bay obviously had a horrible tragedy a little over a week ago, and we as the data community have really come together very strong, showing us support. But if you have a chance, please go find the Data 17 Donates booth, and just anything you can give, $1, $25, whatever you can, just to contribute back to the first responders and to the victims of this tragedy. So, thank you. Oh, and if anybody wants to contact us, these are our Twitter handles. My email address is actually just my first and last name @gmail.com, so you can feel free to contact me at any time. If you ever get stuck through problems, we can set up a hangout meeting and go through things as well.
Any questions? Steve.
Rody, I think the Unicode circles are a great idea, but when we publish the Tableau public, it seems to me when we center text, sometimes it floats a little bit in the user's browsers, and you come across that or found a way around
No, I haven't come across that, actually. Is that, I'll talk to you afterwards. That's interesting. Yeah.
Adam,
Yes.
you plan on updating Game of Thrones, and does the recent season make you pause in saying it's the greatest TV show of all time?
No, sir. But yeah, I'll update the list.
Yeah, Ken.
So I'm curious whether you've seen, well, I know you've seen this used in a business like give you one, but have you seen some of these more unique chart types used in a business environment? Or have you personally done it?
Yes, I have. So nothing as complex as the spiral node link. I think that might be overwhelming. Obviously, all these visualizations depend on your audience and your users. If your users are going to be intimidated by complex chart types, then don't create them. Ultimately, they need to consume them and understand them. But yeah, I've created Sankey's before, chord diagrams. But yeah, 80% of my work, at least, and I'll speak for myself, 80% of the things that me and my teams create are bar charts, line charts, and straightforward charts.
No. Yeah.
In the spiral charting, I come from a network analysis background. So, I'm in the pharma area, so like a key opinion thing. As soon as you know who's connected and what school to go to, that's exactly what they're going to expect to see to understand where those connections are coming from. Right? There's definitely a place for it.
Well, absolutely. And I think with the area bump chart as well, I think there's definitely a use case. I haven't come across that personally, and that's kind of going back to what we said before. It really comes down to the context of your data and your audience. You can have best practices or whatever, but the thing that drives your charts is your data, the questions being asked, and your audience. So that, in your use case, it actually sounds like it would work really well. Is there anyone else? Yeah.
I was just wondering the path field that you were using, is that a calculated field or was that coming from the data source itself?
For which one?
You both used a path field to kind of format the line as you wanted to see it?
So for the area bump chart, it's a calculated field. In that instance, the only reason I have that is because I needed to specifically tell Tableau to draw the top line in one direction, the bottom line in another, so that my polygon would draw correctly. But in our other examples, it's just from the data model.
Yeah, the path ID in mine for the Game of Thrones is just a number that starts at the top of my S curve and goes 2 through 50 all the way down to my 9 o'clock on my face, my watch face.
Thank you.
Yep.
Thank you for the presentation. It was really interesting. I guess I see that there are a lot of somewhat complex trigonometry involved in a lot of this. And maybe it's not complex. It's been a long time since I've studied any of that. But I wonder if you guys have any recommended readings or how to get up to speed on, or a refresh or any sort of that type of,
I use YouTube. YouTube is my best friend in terms of learning trigonometry, calculus, going back to school and some of those things. And then a major way I learn is using the Tableau public community and stealing things from Jeff Schaefer and Christy Martini and Roddy and other people in the community and just reverse engineering what they did and then trying to figure out why did they use a sigmoid function or why did they use a Bezier curve. So that's a good way to get started and then to go figure out why they did something or even just to reach out to them and ask them, what is a Bezier curve? What is a sigmoid function? Why did you use this?
Sure. And then do you have the Alteryx models posted oftentimes? Because I know you said you use a lot of...
I do not.
No.
No. Yeah.
I just actually wanted to add something, and this really goes out to anybody else that's listening. What we're doing seems complex, and I can understand math, scary. I failed calc in college. It's a true story. I am not by any chance a math whiz. But just like with anything in Tableau, it's just hard work. It's just working through a problem, using your resources, going online, going on Wikipedia. Take advantage of this community. Take advantage of the forums, take advantage of blog posts. We're all trying to help each other, we're all trying to get better, and there's so much work out there that's really laid the foundation to allow me to grow to this step. So I highly encourage you to do that. And don't be scared of the journey, it's exciting.
Yep. Yeah. Steal early and often. I mean, Nadia Bremer, Shirley Wu, some of the really talented people. And don't just look in the Tableau community. Look outside the Tableau community because they're not bounded by the software or what's already been done. Yep.
I think,
Go ahead. Yeah. So the question was, do we start with a visualization we want to create and go look for the data, or do we have a data and then try to meet the visualization? The correct answer is you should start with the data and try to create a visualization. And that's what Roddy does correctly. I sometimes do that. This is fun for me. I have a job where I'm doing real stuff and making real things. And so I really just want to make some cool stuff. And so if I have to draw it and then force a data set into that drawing, I have done that. It's not always super successful. But yeah, it's a bit of the chicken or the egg, what comes first. I recommend starting with the data and then getting inspired to create a visualization, but that doesn't always happen.
What he said.
Yeah.
Could you repost the links that you had that with the walkthroughs?
Yep. Yeah. Oh yeah, it's all mine.
Yeah.
Just a quick question. A lot of this seems like practically magic when you're doing it up here. But for context, how long do these things take for you guys to go through them?
That is a great question. It really depends. They're not as long recently because I've been doing these custom chart types so much that I kind of have learned the pattern, I guess you can say, of how Tableau is doing this, so I kind of know what to do beforehand. But when I first started doing this, I think the first Sankey I did took me like a week to figure out, maybe longer, because I was trying to figure out what the heck a sigmoid curve was and trigonometry and stuff. So, I mean, it takes a while when you're getting started. I'm not going to lie to you. It is very difficult. But as you work through that and as you practice more and more and as you come across these custom chart types and really, put your brain to it, it eventually gets easier and you start to learn the concepts, and then, you can start creating these things on the fly.
And yeah, sometimes, it depends. Like the Beatles Viz, I created a Beatles Viz a couple years ago, and that only took, that wasn't very long. It was quick, just because I had the idea and the data and built it rather quickly. The Game of Thrones Viz took a week. I took a while to figure out the math and how to plot the points, and I was stuck on that one for a long while. So it really depends. Sometimes it's a few hours, sometimes it's a few days. Yep. Yeah, I'm a consultant, so I have a hard time sometimes challenging my clients because they're paying me to give them a solution and not really push their, push the boundaries. So it's a trade-off where if they want to see a pie chart and that's what they're comfortable seeing, I try to push them away from a pie chart and more towards a bar chart or something that's more accurate and precise. But yeah, it's a balancing act. I recently posted about gauges versus bullet charts, and so Stephen Few's a big fan of bullet charts, I think because he created them, and he's not a big fan of gauges. But I was building a solution for a client, and I threw a ton of gauges in there, and nobody understood what they meant. They were intimidated by the interquantile range and the reference line, and so it was meaningless that I made a cool, very accurate, precise chart to them. So I put a gauge in there, and everyone has a car. Not everyone has a car, but they all had cars, and they have seen a car gauge before, and they understand how to read a gauge. And even though it's less precise and less accurate, because it's plotting points along a circle, they understood what it meant, and that met their needs. And so, you got to meet them. You got to try to steer them towards what's best and accurate, but also meet them where they are.
And I just want to add on top of that because there's less people in the room. Let's say you're working for a customer, or your audience is an individual, and for whatever reason, this one individual out of 1 million people can read 50 slices of a pie better than they can read a bar chart. Make a 50-slice pie chart. Yeah. It's solely on your audience. I mean, a lot of these best practices are based on studies, and every now and again, you will find somebody who, for whatever reason, can decode values and understand a pie chart better than a bar chart. And when it comes to that situation, the best practice is to do what's best for the audience and what they can best interpret.
Anyone else? Cool. Well, thank you, everyone.
Oh,
sorry. Sorry, say that one more time. Yeah. Yeah, I think obviously both are important. If you can achieve a chart that is both, he's asking about the balance between a chart that is accurately and precise versus it being legible and intuitive. The best chart is something that's both intuitive and accurate and precise, but sometimes a gauge and a bullet chart example, those are not the same thing. And so I tend to lean towards what they're going to be able to understand more than what's going to be precise and accurate. Because ultimately, if it's precise and they don't understand it, it's worse than if they understand it, but it's not, their understanding is not as accurate as you would like them to be. So it's a trade-off. These are not hard and fast rules. These are my opinions. And it depends on the use case. Oh, yeah, sure.
The next one.
This one? Yeah. This is from Andy Kirk. I borrowed a lot of this from Andy Kirk. He has a website which tracks, I don't know, dozens of data visualizations and what COTS products and open source libraries can create these types of charts. And so a lot of this is borrowed heavily from Andy Kirk. What's Andy Kirk's website? Never mind. Just Google Andy Kirk. Visualizing data, thank you. How did I forget that?
Oh, and it's the chart maker directory.
Yep, chart maker directory.
All right, thank you.
Yep, thank you.
Thank you.